A volcano on Russia's Kamchatka Peninsula sent ash 11 kilometers into the sky this month, and the agency tracking it has run out of ways to say what might happen next. Shiveluch sits in the northern third of one of the most violent stretches of the Pacific Ring of Fire, 84 kilometers from the town of Ust-Kamchatsky, 50 kilometers from the village of Klyuchi, and for the better part of June it has been doing something that volcanologists at the Kamchatkan Volcanic Eruption Response Team have flagged repeatedly in the driest language available to a monitoring agency. The aviation code has gone to red more than once. The ash column has reached flight level 350. A lava dome that began forming at the end of last year is still growing, and nobody currently watching it can tell you with certainty whether the growth ends in a pause or in something closer to what this mountain did in 1964. Picture the geography for a moment, because it matters. Kamchatka is a peninsula roughly the size of California, hanging off the eastern edge of Siberia into the Bering Sea, separated from mainland Russia by 1,000 kilometers of nothing that resembles a road. Shiveluch rises near the northern end of it, a stratovolcano built in two parts. An older, broader cone the locals call Old Shiveluch, and beside it, the smaller, far more violent dome complex known as Young Shiveluch, which is the part that has been erupting for more than 2 decades without a true pause. The nearest meaningful settlement, Klyuchi, has fewer than 5,000 residents. Most of the peninsula is uninhabited taiga and tundra, patrolled more by brown bears than by people, which means the people watching this volcano most closely are not residents bracing for evacuation. They are scientists watching satellite thermal imagery and seismometers from hundreds of kilometers away, trying to read a mountain that has a documented history of changing its mind quickly. We want to be precise about what that means, because precision is the only thing that separates a report from a guess. In November of 1964, Shiveluch's summit failed. The edifice came apart. A crater 1.5 kilometers wide by 3 kilometers wide opened where the top of the mountain used to be, and in the space of about an hour and 15 minutes, the volcano produced a directed blast, a Plinian eruption column, and a sequence of pyroclastic flows that together moved more than 2 cubic kilometers of material across the landscape. It remains one of the largest eruptions Kamchatka has produced in the historical record. The volcano has not done that again, but it has been continuously active, in one form or another, since 1999, and what is happening at the summit right now is the kind of activity that has, in the past, preceded the kind of event that does not give much warning. Tonight we are going to walk through exactly what the instruments are recording at Shiveluch this week. The ash plume heights, the dome growth rates, the aviation alerts, and what the Kamchatkan response team is and is not saying about where this goes next. We are going to look at the documented history of this specific volcano, because Shiveluch has produced more large eruptions in the last 10,000 years than almost any other volcano on the peninsula, and the historical record of those eruptions is unusually well preserved. And then we are going to do something that separates this report from every other channel covering this story. We are going to go into the human record of this mountain that predates the instruments entirely, because Kamchatka was inhabited and observed for thousands of years before a single Russian seismometer was ever placed on its slopes, and the people who lived in the shadow of this volcano left behind a description of what lives inside it. That description was recorded, in detail, by the first scientist to ever systematically study this region, and it has a structural correspondence to tonight's data that we think you will find difficult to dismiss as coincidence. We are also going to bring in a second tradition entirely, from a different people, a different language family, and a different relationship to fire and mountains, because the correspondence we are about to show you is not isolated to one culture's account. The people who live across the Kuril chain and into the northern islands of Japan, in the region nearest Kamchatka's southern reach, developed their own elaborate account of what occupies a mountain that burns, and that account was preserved independently of the Kamchatkan material through an entirely separate oral tradition, an entirely separate language family, and a religious framework with almost no documented contact with the people Krasheninnikov was recording further north. And yet, when you place the two records side by side, the structural agreement between them is the kind of thing that should not exist if these were simply two unrelated groups, inventing unrelated explanations for an unrelated phenomenon. And then we are going to set both of those records against a third text, much older, much further from Kamchatka geographically, originating in a tradition with no plausible route of contact with either the Itelmen or the people of the northern islands, that describes mountains opening, fire falling from a darkened sky, and a third of the land being burned. That text has survived for nearly 2,000 years, has been copied, translated, and argued over by serious scholars in every century since, and the specific combination of details it uses to describe a burning mountain is more precise than casual reading usually credits it for. We are not going to tell you what to make of that correspondence. We are going to show you the data, show you the record, and let the comparison speak for itself. Before we get into the agency numbers, it is worth being clear about what this report is and is not. We are not a breaking news channel. If you came here for a 5-minute summary of today's aviation code, there are faster sources for that, and we will name some of them tonight because their reporting has been accurate and worth crediting. What we do is slower. We take an event like this one, verify it against the agencies whose entire function is to monitor it, and then we go looking for the place where that event intersects with the long human record of watching this exact kind of phenomenon. Sometimes that record is scientific. Tonight it includes the work of an 18th century Russian naturalist who walked this peninsula on foot for nearly a decade and wrote down what he saw and what he was told. Sometimes that record is older and harder to date precisely, preserved only in spoken tradition until someone finally transcribed it. We treat both kinds of record with the same standard. If we cannot trace a claim to a real, findable source, we do not use it. Everything you are about to hear is sourced, and the full bibliography is available in this video's description. If you are watching this tonight, we would like to know where you are joining us from. Type your city or your country in the comments below. We read every one, and we have viewers monitoring this channel from every inhabited continent at this point, which tells us something about how widely this pattern of cross-referencing live agency data against historical and ancient record is resonating with people who want more than a headline. If this is your first time with us, we publish a new report most nights, and the format is always the same. We start with what is verifiably happening right now, according to the agencies whose job it is to track it. We do not speculate beyond what the data supports. And then we widen the lens, because the data alone is rarely the whole story, and the historical and ancient record has, more often than people expect, already described what the data is currently showing us. If that is useful to you, subscribing means you do not miss the nights when the pattern lines up in a way that is hard to look away from. Tonight may be one of those nights. The full record starts now. Shiveluch volcano, located at 56.65 degrees north, 161.36 degrees east on Russia's Kamchatka Peninsula, has been in a confirmed active eruptive phase since 1999, and the most recent escalation in that phase began with a sequence of explosive events documented by the Kamchatkan Volcanic Eruption Response Team, known by its acronym KVERT, starting in late May of this year and continuing into June. On June 1st, an explosive event at the summit produced an ash plume that the Tokyo Volcanic Ash Advisory Center, the regional authority responsible for tracking airborne hazards to aviation across the Russian Far East and the North Pacific, measured at 10.8 kilometers above sea level, drifting 280 kilometers to the west. On June 6th, the Tokyo Center issued an advisory measuring continuing ash emissions reaching flight level 350, which corresponds to an altitude of approximately 10.7 kilometers moving north at low speed. By June 8th, KVERT and Russian state monitoring channels had confirmed a second significant eruption within the same week, this one producing an ash column reaching approximately 8 kilometers above sea level, with officials explicitly warning that a stronger eruption, capable of propelling ash as high as 12 kilometers, could occur at any time without further warning. There is a number buried in this month's technical aviation advisories that almost no general coverage of this story has named directly, and it is not a measurement of ash height or wind speed. It is a volume, expressed in cubic kilometers, and it comes from this exact volcano's own history rather than from any live instrument reading. There is also a name, used by the people who lived in this region for thousands of years before any Russian instrument was ever placed on this mountain, for whatever it is they believed lived inside it. We are going to reach both before this report closes, and once you understand what that number measures and what that name describes, the entire shape of what KVERT is and is not currently saying about Shiveluch will look different to you than it does right now. The aviation color code system that KVERT operates under is a 4-tier scale used by volcano observatories worldwide to communicate hazard level to pilots and air traffic authorities. It runs from green, indicating normal background activity, through yellow, indicating elevated unrest, to orange, indicating eruption is underway or imminent with limited ash emission, up to red, the highest tier, indicating eruption is underway or imminent with significant ash emission posing a serious hazard to aviation. Shiveluch has been held at orange for extended stretches across recent months, and during the explosive episodes recorded in late May and early June, the code was elevated to red on multiple separate occasions, each time corresponding to a specific, confirmed explosive event rather than a general escalation of background unrest. This distinction matters. A volcano sitting at orange for months at a time is in a state of sustained, monitored unrest. A volcano spiking to red and then returning to orange repeatedly over a period of weeks is a volcano whose internal pressure is finding release through a sequence of discrete explosive events rather than a single sustained eruption, and reading that pattern correctly is part of what separates a useful hazard assessment from a panic headline. The lava dome at the center of this activity, known to volcanologists studying the mountain as the Young Shiveluch Dome Complex, has a documented growth history that KVERT has been tracking since at least late February of this year, when the monitoring station Volkstat, operated by Russian volcanologists working the peninsula, first noted that a new dome had begun extruding on the western portion of the existing dome structure within the crater floor. By the end of February, this new dome had already grown taller than the dome structure it was emerging from. Through March, April, and May, that growth continued, punctuated by explosive events of increasing frequency, and by the final week of May into the first week of June, the explosive frequency had increased to the point where multiple distinct ash-producing events were being recorded within a single 7-day window, a tempo Kamchatkan volcanologists have specifically associated in past eruptive cycles at this volcano, with periods preceding either a partial dome collapse or a significant escalation in eruptive intensity. To understand why that association matters, it helps to understand what kind of volcano this is, structurally, and why its specific failure mode differs from the failure mode of volcanoes most viewers will be more familiar with from other recent coverage. Shiveluch is not a basaltic shield volcano producing slow-moving lava flows, the way Kilauea in Hawaii does, where eruptions tend to be visually spectacular but comparatively predictable in their behavior once an episode begins. Shiveluch is an andesitic to dacitic stratovolcano, meaning its magma is thicker, more viscous, and holds gas under higher pressure before release, the same broad category of volcanic behavior responsible for some of the most destructive eruptions in the modern instrumental record, including Mount St. Helens in 1980 and Mount Pinatubo in 1991. Volcanoes of this type build lava domes when magma reaches the surface, but is too viscous to flow away. Instead, it piles up directly over the vent, growing taller and structurally more unstable over time, until either the dome collapses under its own weight, producing fast-moving pyroclastic flows down the volcano's flanks at speeds that can exceed 100 kilometers per hour, or internal gas pressure builds past the point the dome structure can physically contain, producing an explosive eruption capable of partially or entirely destroying the dome in a single event measured in minutes rather than hours. Shiveluch has done both, repeatedly, across its documented history, and we will examine that documented history in close detail in the section that follows this one. For now, the current agency data, as of the most recent KVERT and affiliated monitoring updates available at the time this report was filed, the aviation color code for Shiveluch stands at orange, following the most recent red-level explosive event. Seismic activity beneath the volcano remains above background levels, with KVERT's bulletins specifically noting continued elevated tremor consistent with active magma movement at shallow depth. Thermal anomaly detection via satellite, which measures surface and near-surface heat signatures consistent with magma at or very near the surface, has been recorded on the majority of clear sleep observation days throughout the current monitoring period, with cloud cover the primary obstacle to continuous satellite tracking, a persistent operational challenge given Kamchatka's frequently overcast weather patterns, particularly in the early summer months. Ashfall from the early June explosive sequence was documented across a wide downwind area. Heavier accumulation was reported in and around Klyuchi and Ust-Kamchatsky, the two population centers closest to the volcano, with residents in Klyuchi specifically reporting visible ash deposition and reduced visibility during the more significant explosive episodes. Officials have stated, as of the most recent updates available, that mass evacuation has not been deemed necessary, with monitoring focused instead on residents with respiratory or other health vulnerabilities who may require precautionary relocation should conditions worsen. This is consistent with how Kamchatkan authorities have handled comparable ash events at this volcano in past years. A November 2024 explosive sequence at Shiveluch, for comparison, coated more than 7,000 square kilometers of territory in ash, disrupted regional flights, and prompted the regional governor to state publicly that no mass evacuation was required, while still authorizing targeted evacuation for residents with documented health conditions, a near-identical posture to the one currently in effect. 3 agencies are doing the work of watching Shiveluch right now, and it is worth naming each one and explaining precisely what it does, because their roles are distinct and their authority comes from different institutional sources. The first is KVERT itself, the Kamchatkan Volcanic Eruption Response Team, a joint operation run through the Institute of Volcanology and Seismology of the Far Eastern Branch of the Russian Academy of Sciences, in long-standing cooperation with the Alaska Volcano Observatory and the United States Geological Survey. KVERT exists specifically because Kamchatka's volcanoes sit directly beneath some of the busiest transpacific aviation corridors on Earth, the routes connecting North America and Europe to East Asia, and a significant, unanticipated ash event at a Kamchatkan volcano has the demonstrated potential to disrupt international air travel on a scale most people do not associate with a remote Russian peninsula most viewers would struggle to locate on a map without assistance. KVERT's daily and as-needed bulletins are the primary technical source underlying everything in this report regarding current activity levels, seismicity, and dome growth measurements. The second agency is the Tokyo Volcanic Ash Advisory Center, one of 9 volcanic ash advisory centers operated globally under a coordinated system established through the International Civil Aviation Organization, with Tokyo Center holding responsibility for the airspace covering Japan, the Russian Far East, and the broader Northwest Pacific. Tokyo's advisories translate KVERT's ground-based and seismic data into the specific altitude and drift information that pilots and airlines use to reroute around hazardous airspace in real time, often with only hours of lead time. When we cited flight level 350 earlier in this report, that figure came directly from a Tokyo Center advisory, cross-referenced against satellite imagery from the Himawari 9 weather satellite, which provides the visual confirmation analysts use to verify that an ash plume is behaving the way ground-based, seismic, and infrasound data suggests it should be behaving, a cross-verification step that has become standard practice across volcanic ash advisory centers globally, following several near-miss aviation incidents in past decades involving aircraft inadvertently flying through unconfirmed ash clouds. The third agency relevant to tonight's report is the Global Volcanism Program, jointly operated by the Smithsonian Institution and the United States Geological Survey, which maintains what is widely regarded as the most complete long-term eruptive history database for every actively monitored volcano on Earth, Shiveluch included. The Global Volcanism Program's archive is what allows volcanologists, and what allows us, to place this month's activity in the context of documented eruptions stretching back centuries, and it is the primary source underlying the historical eruption sequence we are about to walk through in detail in the section that follows. Here is what is happening at this precise moment, as best as the available data allows us to characterize it without speculation. The dome at the summit of Young Shiveluch continues to grow. Magma continues to rise into that dome from depth, based on sustained thermal signature and sustained low-level seismicity. Gas, primarily water vapor, carbon dioxide, and sulfur dioxide, continues to vent both through the dome surface in a steady degassing plume and through episodic explosive release, the same explosive release that has repeatedly pushed the aviation code to red over the past several weeks. The secondary effects of this activity extend well beyond the immediate vicinity of the volcano itself. Ashfall has, during past comparable eruptive episodes at this exact volcano, been documented reaching as far as the regional capital, Petropavlovsk-Kamchatsky, more than 400 kilometers from the volcano, depending entirely on wind direction at altitude during a given explosive event. International flight routes through the broader region have required active rerouting during periods of red level activity, a recurring operational cost that airlines flying the Transpacific Northern Pacific routes have learned to factor into their seasonal planning around Kamchatkan volcanic activity. Generally, and around Shiveluch specifically, given its position and its documented frequency of significant ash-producing events compared to most of the peninsula's other active volcanoes, the monitoring infrastructure tracking all of this deserves closer attention because it represents one of the more sophisticated volcanic early warning networks operating anywhere on Earth, built specifically because the alternative, a major unanticipated eruption disrupting transpacific aviation without adequate warning, carries consequences extending far beyond Kamchatka itself. Seismometers positioned around Shiveluch's base detect the characteristic tremor signatures associated with magma movement at depth, signatures that are structurally distinct from the tectonic earthquake signatures associated with the broader seismicity of the Kamchatka subduction zone, where the Pacific plate is being forced beneath the Eurasian plate at a rate of roughly 80 millimeters per year, among the faster subduction rates documented anywhere on the planet, and the underlying geological reason Kamchatka hosts approximately 30 currently active volcanoes along a peninsula roughly comparable in length to the state of California. Satellite-based infrared and thermal sensors, primarily from the Himawari series of Japanese weather satellites and supplemented by polar orbiting NASA and NOAA satellites passing overhead multiple times daily, provide continuous thermal anomaly detection, allowing analysts to track dome growth and identify the onset of new explosive activity, even when ground-based observers cannot safely approach the volcano or when persistent cloud cover obscures direct visual confirmation for days at a stretch. Infrasound monitoring, which detects the very low-frequency sound waves produced by volcanic explosions, frequently well below the threshold of human hearing, provides near-instantaneous confirmation that an explosive event has occurred, often arriving before satellite imagery can confirm the resulting ash plume's altitude and drift direction, giving aviation authorities crucial additional minutes to reroute air traffic before an aircraft encounters hazardous airspace. There is a specific detail in the explosive sequence from the first week of June that KVERT's technical bulletins recorded and that deserves attention here, because it is the kind of detail easily lost in summary news coverage, but significant to anyone tracking this volcano's behavior closely over time. The early June explosive events did not emerge from a quiet baseline period. KVERT's bulletin from the preceding days specifically described continuing eruptive activity at the lava domes along the northern crater floor in the days immediately before the more significant explosions, meaning the escalation built directly on top of an already elevated activity level rather than emerging suddenly from calm. We are going to return to why that specific pattern, an already active system producing a further explosive escalation rather than a quiet system erupting without warning, has a documented historical parallel at this exact volcano worth understanding in full before we go any further into tonight's report. That number will matter later in this report. Keep it in mind, because it is going to recontextualize the live data we have just walked through. The historical eruption record for Shiveluch, maintained by the Global Volcanism Program, documents at least 60 large explosive eruptions at this volcano during the Holocene epoch, the roughly 12,000-year period since the end of the last ice age, making it one of the most frequently and violently active volcanoes on the entire Kamchatka Peninsula, itself one of the most volcanically active regions on the surface of the Earth. Within that long record, 2 eruptions stand out as catastrophic by any reasonable scientific standard. An eruption in 1854, documented as a Plinian eruption, meaning a sustained, towering eruption column comparable in style and intensity to the eruption that destroyed Pompeii and Herculaneum in 79 CE, and the eruption of November 12th, 1964, which produced what remains one of the most violent volcanic events recorded anywhere on Kamchatka in the modern era, an event we will devote considerable and specific attention to in the section that follows. We want to be careful and precise here, because precision is the entire point of this report. We are not claiming that current activity at Shiveluch means a 1964 scale event is imminent. The agencies tracking this volcano in real time have not made that claim, and we are not going to make it on their behalf, because doing so would be the kind of unfounded escalation that erodes trust rather than building it. What we can say, with full confidence in the sourcing behind it, is this. The volcano currently producing sustained dome growth, repeated red-level aviation alerts, and an explosive sequence that has intensified over the past several weeks is the same volcano whose documented history includes catastrophic edifice failure that, when it has happened before at this exact location, occurred with limited advance warning, following a period of activity that observers and instruments at the time also could not characterize with certainty as either a precursor to catastrophe or simply another cycle of ordinary, if locally violent, dome-building behavior. That uncertainty is not a failure of the monitoring system currently in place. It is an honest reflection of how this specific class of volcano actually behaves, and understanding that uncertainty plainly is more useful and more respectful of the people living closest to this mountain than pretending the uncertainty does not exist. There is a name attached to this exact stretch of Kamchatka's northern coast, attached specifically to this volcano, in a record that predates every instrument we have just described by roughly 2.5 centuries, and we have not yet introduced it. We are not there yet. We will get there, and when we do, the correspondence between what that record describes and what the agency data we have just walked through is currently recording will be difficult to set aside as mere coincidence. It is worth placing Shiveluch within the broader volcanic context of the peninsula it sits on, because the scale of what is being monitored here is easy to underestimate from outside the field. Shiveluch belongs to what volcanologists classify as the Klyuchi volcanic group, a cluster of roughly a dozen active and recently active volcanoes concentrated in north-central Kamchatka, named for Klyuchevskaya Sopka, the tallest active volcano in Eurasia, at just under 4,800 meters, which sits less than 50 kilometers from Shiveluch and has itself been in a near-continuous state of activity for centuries. This concentration of major active volcanic systems within such a compact geographic area exists because of the specific geometry of the subduction occurring offshore, where the Pacific Plate's descent beneath the Kamchatka block generates exceptionally productive and exceptionally hot magma sources at relatively shallow depth, feeding multiple separate volcanic edifices simultaneously. KVERT's mandate covers the entire Klyuchevskaya group, along with the rest of Kamchatka's roughly 30 currently active systems, which means the team issuing today's bulletins on Shiveluch is, at any given time, also tracking activity at Klyuchevskaya Sopka itself, at Bezymianny, the volcano whose catastrophic 1956 directed blast eruption became the scientific template later used to understand Mount St. Helens in 1980, and at several other systems in varying states of unrest. Shiveluch's current activity has not, as of this report's filing, been linked to any change in status at the neighboring volcanoes in the group, and KVERT's bulletins have treated this as an isolated escalation specific to Shiveluch's own magmatic system rather than a broader regional event, a distinction the agency has been careful to maintain across its public communications. The economic and operational dimension of this story deserves more attention than it typically receives in standard news coverage, because it is the dimension that connects a remote volcano most viewers will never visit to decisions being made on flight decks and in airline operations centers thousands of kilometers away on the same day the ash advisory is issued. The Great Circle routes connecting major hub airports in North America, including Anchorage, Vancouver, and several major American gateway cities, to destinations across East Asia, including Tokyo, Seoul, and several Chinese hub cities, pass directly across or immediately adjacent to Kamchatkan airspace for a significant portion of their flight path, a routing dictated by the curvature of the Earth rather than by any preference for flying near active volcanoes. When Shiveluch's aviation code rises to red and the Tokyo Volcanic Ash Advisory Center issues an advisory placing ash at flight level 350, the altitude band most long-haul commercial aircraft cruise within, airlines operating these routes face a direct operational choice: reroute around the affected airspace, typically adding meaningful flight time and fuel cost, or in more severe cases, delay or cancel flights until the advisory is downgraded. This is not a hypothetical cost. It has happened repeatedly across Shiveluch's eruptive history, most notably during the volcano's more significant ash events in past years, when sustained high-altitude ash plumes forced extended rerouting across multiple consecutive days. The current explosive sequence, while producing shorter duration ash events than some past episodes, has already required the kind of advisory-driven rerouting that airlines flying these corridors have learned to anticipate as a recurring seasonal cost of operating routes that pass near one of the most consistently active volcanic regions on Earth. There is also a slower, quieter dimension to this story that rarely makes it into coverage focused on the dramatic ash column imagery, and that is the long-term environmental and agricultural impact of repeated ashfall on the communities closest to the volcano. Klyuchi and the surrounding settlements sit within a region where subsistence, fishing, small-scale agriculture, and reindeer herding remain economically significant activities, much as they have for centuries, and repeated heavy ashfall events, even when they do not rise to the level of triggering evacuation, have documented cumulative effects on soil chemistry, water sources, and grazing land that the communities living closest to Shiveluch have had to adapt to managing across generations, well before any Russian or Soviet monitoring agency existed to track the volcano scientifically. This is not a detail the live agency data captures, because it falls outside the mandate of aviation-focused monitoring, but it is a detail the historical and ancient record we are about to examine captures very directly, because the people who lived here longest were the ones who had to develop a working relationship with this mountain's behavior long before anyone called it Shiveluch. Before we move into that historical and ancient material in full, it is worth walking through the instrumental eruption record at this specific volcano in more detail than we have so far, because the pattern within that record, established well before tonight's event and entirely independent of any ancient or oral source, is itself the foundation for everything that follows. The Global Volcanism Program's archive lists confirmed or probable eruptions at Shiveluch in 1739, in 1800, in 1854, across a sustained period from 1879 through 1883, again in 1897 and 1898, in 1905, across 1928 and 1929, in 1930, across an extended episode from 1944 through 1950, in 1964, across 1980 and 1981, in 1984, 1985, across 1986 through 1988, again in 1988 and 1989, across 1990 through 1994, in 1997, in 1998, in 1999, and then continuously from 1999 to the present day without a documented break long enough to be classified as a true eruptive pause rather than a temporary lull. That is, by any reasonable count, more than 24 distinct eruptive episodes across roughly 285 years of written observation, a frequency that places Shiveluch among the most consistently active andesitic stratovolcanoes documented anywhere on Earth, and that frequency itself is part of why the volcano has accumulated the kind of long, detailed observational record that allows the comparison we are building toward tonight. Two of those episodes, the 1854 eruption and the 1964 eruption, are classified by volcanologists as significantly more violent than the others, and both are worth understanding in some structural detail before we proceed, because the current activity at Shiveluch while serious and worth monitoring closely, has not approached the scale of either. The 1854 eruption is documented as Plinian in style, meaning it produced a sustained, towering column of ash and gas reaching well into the stratosphere, sourced from a sudden, large volume release of gas-charged magma, the same basic eruptive style, on a smaller overall scale as the eruption that buried Pompeii in the year 79. Detailed instrumental records from 1854 do not exist in the way they would for a modern eruption, because the instruments that exist today simply did not exist then, but the eruption left a substantial physical footprint in the geological record, a large crater and extensive pyroclastic flow deposits that volcanologists have mapped and dated using methods developed long after the eruption itself occurred, allowing the event to be reconstructed with reasonable confidence despite predating any direct seismic or satellite observation. The 1964 eruption is the one with by far the most complete scientific reconstruction, because it occurred during the Soviet era, when Kamchatka's volcanoes had already become subjects of serious scientific study, and because its scale demanded the kind of detailed post-eruption analysis that smaller events do not receive. In the day before the eruption began, seismic instruments recorded 73 distinct earthquakes beneath the volcano, a number that, read in isolation, might not have seemed dramatic to observers at the time. In the 7 hours immediately preceding the eruption's onset, that seismicity became nearly continuous, a pattern that, with the benefit of decades of subsequent volcanological research, is now recognized as a classic precursor signature for the kind of edifice failure that followed. Though, at the time, with the science of eruption forecasting still in a comparatively early stage, the exact significance of that accelerating seismicity was not, and arguably could not have been, fully appreciated in real time by the observers tracking it. At 705 hours local time on the morning of November 12, 1964, the summit of Shiveluch failed. The sequence, as later reconstructed through detailed deposit mapping and comparison with similar eruptions elsewhere, unfolded as follows. First, an edifice failure, in which a substantial portion of the volcano's summit structure collapsed, involving an estimated 1.15 cubic kilometers of material and opening a crater approximately 1.5 kilometers by 3 kilometers wide, where the summit had previously stood. This was followed by a smaller phreatic explosion caused by the sudden contact between hot volcanic material and groundwater or ice, ejecting a further 0.01 cubic kilometers of resurgent ash. Then, between approximately 7:20 and 7:47 that same morning, a sustained Plinian eruption phase produced an estimated 0.3 cubic kilometers of fresh andesitic material, the magma that had been driving the unrest in the first place finally reaching the surface in volume. Finally, in the eruption's last and most destructive phase, between 7:47 and 8:22 that morning, pyroclastic flows totaling an estimated 0.3 to 0.5 cubic kilometers swept down the volcano's flanks. The fast-moving, superheated mixture of gas and volcanic debris that represents one of the most lethal hazards any explosive volcano can produce. In total, the 1964 eruption moved on the order of 1.75 to 2 cubic kilometers of material in a sequence lasting just over an hour, and ash and pyroclastic deposits from the event ultimately covered nearly 100 square kilometers of the surrounding landscape. That is the number we asked you to keep in mind earlier in this report. Nearly 2 cubic kilometers of material moved in roughly 75 minutes by a volcano that had given observers 73 earthquakes the day before and several hours of nearly continuous seismicity immediately before the edifice failed, a pattern of escalating, already elevated activity producing further escalation rather than a quiet system suddenly erupting from calm, structurally the same pattern KVERT's bulletins have described in the explosive sequence currently unfolding at this volcano in early June of this year. We want to restate clearly what we said earlier and what we are not claiming. Current seismicity at Shiveluch has not approached anything close to the tempo recorded in the hours before the 1964 failure, and KVERT's own bulletins give no indication that anything resembling a 1964 scale edifice failure is presently underway or imminent. What we are pointing out, soberly and on the documented record, is that the qualitative pattern, an already active dome-building system producing an escalating sequence of explosive events over a period of weeks, is the same broad pattern that, 62 years ago at this exact volcano, eventually culminated in the most violent eruption in this mountain's modern instrumental history. Whether the current sequence resolves the way most of Shiveluch's 24+ other eruptive episodes have resolved, through a period of dome growth and explosive venting that eventually subsides without catastrophic failure, or whether it follows the rarer path the volcano took in 1854 and again in 1964, is not something the agencies tracking it can currently answer with certainty, and we are not going to pretend otherwise. There is one further piece of instrumental context worth adding before we move into the historical and ancient material proper, because it bridges the gap between the purely scientific account we have just given and the older human record we are about to introduce. Researchers who have studied Shiveluch directly, including geologists who have conducted fieldwork on the volcano's slopes in recent years, have specifically noted the difficulty of predicting this volcano's behavior precisely because of how frequently its activity oscillates between sustained, relatively low-intensity dome growth and sudden, high-intensity explosive episodes, sometimes with limited advance warning, even with the benefit of modern seismic, satellite, and infrasound monitoring working in concert. That difficulty, acknowledged by the scientists with the most direct, hands-on familiarity with this exact mountain, is the same difficulty that the people who lived in this region across the centuries before any of those instruments existed also had to confront, using the only tools available to them at the time: sustained, careful, generational observation, and an oral tradition built to encode and transmit what that observation taught them. We will return to the historical record once more before this report closes, and the second retention point we want to plant here concerns a detail in the 2024 comparison event we mentioned earlier, a detail we have deliberately held back until now. That November 2024 explosive sequence, the one that coated more than 7,000 square kilometers in ash, was itself preceded by a similar pattern of escalating, already active dome growth, recorded by KVERT in the weeks beforehand, in language nearly identical to the language used in this year's bulletins. The 2024 sequence resolved without catastrophic edifice failure. The dome continued growing afterward. We mention this not to suggest the current sequence will necessarily resolve the same way, because no agency can promise that, but to be fair and balanced about what the recent comparative record actually shows, explosive escalation at Shiveluch has, in the most recent prior instance available for direct comparison, resolved without catastrophe. The volcano's much longer record, stretching back to 1,854 and 1,964, shows that this is not always how the pattern resolves. Holding both of those facts together, without letting either one cancel the other out, is the only fair way to read what is happening at Shiveluch right now, and it is the same balance the deeper historical and ancient record we turn to next will ask you to hold as well. It is worth pausing on exactly how KVERT, the Tokyo Center, and the Global Volcanism Program coordinate with one another in practice, because the relationship between these three institutions is not simply a matter of each one operating independently and occasionally citing the others. KVERT's ground-based and satellite-derived observations are transmitted to the Tokyo Volcanic Ash Advisory Center in near real time whenever activity at any Kamchatkan volcano crosses a threshold warranting an aviation advisory, and Tokyo S advisories are in turn distributed automatically to airlines, air navigation service providers, and aviation authorities across the entire Northwest Pacific region through a standardized international messaging system specifically designed for volcanic ash hazard communication, a system built in the decades following several serious aviation incidents in which commercial aircraft inadvertently flew through unconfirmed ash clouds and suffered significant engine damage as a result. Incidents that fundamentally reshaped how seriously the global aviation industry now treats volcanic ash forecasting. The Global Volcanism Program, for its part, does not issue real-time hazard advisories at all. Its function is archival and synthetic, compiling the bulletins issued by KVERT, the Tokyo Center, and dozens of other regional volcano observatories worldwide into a single, standardized, long-term historical record that allows exactly the kind of before and after comparison we have been building throughout this report. Without that archival function, comparing this month's activity to the 1964 eruption in any rigorous way would not be possible, because the raw observational records from 1964 exist in scattered Soviet-era scientific literature that the Global Volcanism Program synthesis work has done the labor of standardizing and making accessible. The specific data points KVERT tracks on a continuous basis beyond the headline ash plume heights that make it into general news coverage include the rate of dome growth measured through repeat satellite imagery, and when conditions allow, direct visual or photographic survey, the frequency and amplitude of seismic events specifically associated with magma movement as distinct from the broader tectonic seismicity of the region, the rate and composition of gas emissions, particularly sulfur dioxide, measured through specialized satellite instruments capable of detecting volcanic gas plumes from orbit, and the surface temperature of the dome itself, tracked through thermal infrared imaging, which provides an indirect but useful proxy for how close fresh magma sits to the surface at any given time. Taken together, these data streams allow KVERT's analysts to construct a continuously updated picture of the volcano's internal state. Even though the actual magma chamber feeding Shiveluch sits many kilometers below the surface, far beyond the reach of any direct observation, and must instead be inferred from how its pressure and composition manifest in the surface and near-surface signals these instruments are capable of detecting. This is, in a meaningful sense, the central challenge of all modern volcanology, and it is worth stating plainly because it directly informs how this report approaches the historical and ancient material that follows. No instrument currently available to science can see directly into a volcano's magma chamber and read its future behavior with certainty. Every forecast, every aviation advisory, every alert level KVERT issues is an inference built from indirect surface signals, informed by the documented behavior of this exact volcano and similar volcanoes elsewhere across the historical and instrumental record. The people who lived on this peninsula for thousands of years before any seismometer existed were engaged in fundamentally the same project using a different, but not unsophisticated, set of tools. Sustained, multi-generational observation, careful attention to the specific warning signs that preceded past eruptions within living or orally transmitted memory, and a cultural framework built to encode and transmit that observational knowledge forward to people who had not personally witnessed the events being described. Whether that framework took the form of religious or spiritual language, as it did for the Itelmen and Koryak peoples who lived closest to Shiveluch, does not, on its own, tell us anything about whether the underlying observations being encoded were accurate. It only tells us about the cultural form the observation took. Whether the content of that observation has anything truly useful to tell us about this volcano's behavior is a question we can only answer by examining the specific record directly, which is exactly what we are about to do. It is also worth situating Shiveluch within the largest possible frame before we narrow our focus, because the volcano's behavior, however significant on its own terms, is one data point within a much larger system that has been unusually active in the broader sense across this same general window. The Pacific Ring of Fire, the roughly 40,000 kilometer horseshoe of subduction zones, volcanic arcs, and major fault systems encircling the Pacific Basin, hosts the overwhelming majority of the planet's active volcanism and a substantial majority of its largest earthquakes, the product of multiple oceanic plates being continuously consumed at the boundaries where they meet the surrounding continental and oceanic plates. Kamchatka sits at one of the more geologically active nodes along that entire ring, a position shared with the volcanic arcs of Japan, the Kuril Islands, the Philippines, Indonesia, and the western coast of the Americas, all of which have, across this same general period, produced their own significant seismic and volcanic activity, a reminder that no single eruption, however dramatic, occurs in true geological isolation from the broader system it belongs to. We mention this not to draw a direct causal connection between Shiveluch's current activity and events occurring elsewhere along the ring, which the available science does not support, but because the historical and ancient traditions we are about to examine consistently describe this entire category of phenomenon: mountains opening, fire and smoke rising from the earth, the ground shaking, and the sea responding in turn. As a connected and recurring feature of the world these traditions' originators inhabited, rather than as a series of unrelated, isolated incidents. That framing, encoded independently across multiple unrelated traditions on opposite sides of the Pacific, is itself a pattern worth taking seriously on its own terms, regardless of what one ultimately concludes about its cause. It is worth returning briefly to the November 2024 comparison event in more detail than we gave it earlier, because the specifics matter for an honest reading of what might come next. During that episode, regional authorities reported that ash fell across more than 108,000 square kilometers of Kamchatkan territory, an area regional scientists at the time described as the largest single ashfall footprint the peninsula had experienced in nearly 6 decades, a span of time that, not coincidentally, reaches back almost exactly to the 1964 eruption itself. Klyuchi specifically recorded an ash layer roughly 8 centimeters thick during that event, thick enough that residents posted videos showing the settlement plunged into a daytime darkness, usually associated with a total solar eclipse rather than an ordinary afternoon. 2 villages lost power for several hours as ash interfered with electrical infrastructure. The regional governor, addressing the public directly, stated there was no need for mass evacuation, while explicitly noting that residents with existing health conditions could be offered temporary relocation if needed, language nearly identical to the language Kamchatkan officials have used in response to the current sequence. That 2024 event, by the standards of Shiveluch's own multi-century record, was significant. Among the largest ashfall footprints the volcano has produced since written observation began, and it still did not escalate into anything resembling the structural failure the volcano experienced in 1854 or 1964. We raise this not to suggest the current activity is therefore safe to dismiss, but because an honest report owes its audience the full comparative picture, including the instances where escalating activity at this volcano did not lead to catastrophe, alongside the instances where it did. The broader Klyuchevskaya volcanic group, which we introduced earlier, deserves slightly more detail here as well, because understanding the neighbors helps calibrate exactly how unusual or ordinary Shiveluch's current behavior actually is within its own geological context. Klyuchevskaya Sopka itself, the group's namesake and the tallest active volcano in all of Eurasia, has erupted more than 40 times since observations began in the 18th century, placing it in a similar activity class to Shiveluch, though its eruptions tend toward more fluid basaltic andesitic lava flows and Strombolian-style explosive activity rather than the thick, dome-building, occasionally catastrophic behavior that characterizes Shiveluch specifically. Bezymianny, a smaller volcano in the same cluster, was considered extinct or long dormant until a sudden, violent eruption in 1956 produced a directed lateral blast that flattened forest across roughly 500 square kilometers, an event that, at the time, surprised volcanologists precisely because the volcano had shown no prior indication of being capable of that scale of violence, and which subsequently became the primary scientific reference point used to understand and anticipate the 1980 Mount Street. Helens' eruption a quarter-century later, once geologists recognized the structural similarity between the two events. The existence of Bezymianny's history within the same volcanic cluster as Shiveluch is itself a sober data point worth holding alongside everything else in this report. It demonstrates, within this exact group of mountains, that a volcano can transition from apparent quiet to catastrophic, largely unanticipated violence, which is precisely the kind of outcome the agencies monitoring Shiveluch today are working to rule out, or to provide adequate warning ahead of, through the continuous, layered monitoring system we have described throughout this section. We want to draw this portion of the report to a close by stating, one final time and as plainly as the data allows, exactly where things stand. Shiveluch is in an active, escalating eruptive sequence, confirmed independently by KVERT, the Tokyo Volcanic Ash Advisory Center, and satellite observation from multiple national space agencies. The aviation hazard is real and ongoing, and has already required operational responses from commercial aviation across the region. The volcano's documented history includes both episodes that resolved without major incident and at least 2 episodes in 1854 and 1964 that did not. The agencies responsible for tracking this mountain in real time have been honest about the limits of what current instrumentation can predict, and this report intends to be equally honest about those same limits, rather than manufacturing false certainty in either direction, toward alarm or toward reassurance. In the coming days, the specific thresholds worth watching, according to KVERT's own stated monitoring framework, include any further acceleration in the frequency of explosive events beyond what has already been recorded this month, any sustained increase in seismic tremor amplitude beyond current background elevated levels, any indication of new ground deformation at the summit suggesting a structural change in the dome rather than simple continued growth, and any escalation in sulfur dioxide emission rates beyond the range KVERT has documented across the current sequence. None of those thresholds have been crossed as of this report's filing. All of them are being tracked continuously, hour by hour, by the agencies whose entire function is to notice the moment any one of them changes. It is worth adding one final note on methodology before we leave the live data behind, because it speaks directly to why this report has leaned as heavily as it has on KVERT's own published bulletins rather than on secondary news coverage of those bulletins. KVERT publishes its findings in a standardized format specifically designed for international distribution to aviation authorities, meaning the underlying data is written to be precise, technical, and resistant to the kind of interpretive drift that can creep in when a finding passes through several layers of summary before reaching a general audience. A wire report describing Shiveluch's activity as merely escalating loses the specific altitude figures, the specific dates, and the specific distinction between orange and red that actually determine what airlines and regional authorities do in response. Tonight's report has tried, wherever possible, to preserve those specifics rather than smoothing them into the kind of vague characterization that makes for an easier headline but a less useful account of what is actually happening at this volcano this week. That is the modern record, complete and sourced, exactly as the agencies responsible for monitoring this mountain have reported it. We do not stop there. There is an older layer attached to this exact place, predating every seismometer and every satellite we have just described, recorded by the people who watched this mountain longest and who left behind a description of what they understood to be living inside it. That description was written down in careful and surprisingly systematic detail by the first scientist Russia ever sent to study this region, and it is where we turn next. The instrumental record we just walked through, the eruptions in 1854 and 1964 specifically, is itself a kind of historical echo, a documented precedent for what escalating activity at this exact volcano has produced before. But there is a wider historical pattern worth examining, drawn from comparable stratovolcanoes elsewhere that share Shiveluch's specific eruptive style, that helps calibrate just how seriously the current sequence deserves to be taken. The clearest parallel is Mount St. Helens in Washington state, in the spring of 1980. In the 2 months before that volcano's catastrophic May 18th eruption, seismologists recorded a sustained pattern of escalating seismicity beneath the mountain, beginning with a single moderate earthquake on March 20th, intensifying through hundreds of smaller events over the following weeks, accompanied by visible deformation of the volcano's north flank, a bulge that grew outward at a documented rate of roughly 1.5 meters per day through April and into May, a rate of structural change geologists at the time described as unlike anything previously measured at an actively monitored volcano. United States Geological Survey scientists, led by David Johnston, who would himself die in the eruption while manning an observation post, were explicit in public statements throughout April and early May that the mountain was behaving in a way consistent with an impending major eruption, while also being honest that the precise timing remained impossible to forecast with certainty. When the eruption came, It began with a magnitude 5.1 earthquake that triggered the largest landslide in recorded human history, followed within seconds by a lateral, sideways directed blast, structurally similar to what Bezymianny produced in 1956 and what Shiveluch itself has the documented capacity to produce, that flattened standing timber across roughly 600 square kilometers and killed 57 people. The parallel to tonight's report is not that Shiveluch is currently exhibiting deformation on the scale Mount Street. Helens showed in 1980 because it is not based on everything KVERT has published. The parallel is structural, a dome building, andesitic stratovolcano, displaying escalating but ambiguous precursor activity, monitored by scientists who were honest in real time about the limits of what they could predict, right up until the moment prediction became unnecessary because the event had already begun. That number will matter again before this section closes. Keep it in mind. A second parallel, geographically much closer to Shiveluch and drawn from the same broader volcanic system, is the 1,991 eruption of Mount Pinatubo in the Philippines, which stands as one of the largest volcanic eruptions of the 20th century and one of the rare instances in modern volcanology where a major eruption was successfully forecast with enough lead time to evacuate tens of thousands of people before the climactic event. Pinatubo had been dormant for roughly 500 years before reawakening in 1991, and the Philippine Institute of Volcanology and Seismology, working in direct cooperation with the United States Geological Survey, tracked an escalating sequence of steam explosions, seismicity, and sulfur dioxide emission increases over a period of approximately 10 weeks before the climactic eruption on June 15th, 1991, successfully issuing progressively more urgent alert levels that ultimately prompted the evacuation of more than 60,000 people from the danger zone, an evacuation credited with saving an estimated 5,000 to 20,000 lives that would otherwise have been lost. Pinatubo's eruption column reached approximately 35 kilometers into the stratosphere, among the highest ever recorded, and its sulfur dioxide injection into the upper atmosphere was significant enough to measurably cool global average temperatures for the following 2 years, a documented climatic effect studied extensively in subsequent decades. The Pinatubo case demonstrates something important, and in its own way, hopeful, that the same kind of monitoring infrastructure currently watching Shiveluch, escalating seismicity, ground deformation, gas emission tracking, has, in at least one major documented instance, successfully provided enough warning to save tens of thousands of lives, even at a volcano with no recent eruptive history to draw on for comparison, unlike Shiveluch, which has nearly 3 centuries of documented precedent for scientists to work from. There is a name in the historical record that matches this location precisely. We are not there yet. A third and final comparative case worth examining briefly is the documented eruptive history of Kilauea in Hawaii, not because Kilauea shares Shiveluch's magma chemistry or eruptive style, since it does not, but because Kilauea's exceptionally well-instrumented modern monitoring history offers a useful contrast that sharpens exactly what makes Shiveluch's situation distinct. Kilauea's basaltic system produces eruptions that, while sometimes destructive to property, are comparatively predictable once underway, with lava fountaining episodes that scientists at the Hawaiian Volcano Observatory have, in recent years, forecast with increasing precision down to specific multi-day windows based on tiltmeter readings tracking summit inflation and deflation cycles with a regularity that andesitic dome-building volcanoes like Shiveluch simply do not exhibit. The contrast is instructive. Hawaiian-style basaltic volcanism, despite producing visually dramatic eruptions, tends toward a kind of mechanical regularity that makes forecasting comparatively tractable. Andesitic stratovolcanoes like Shiveluch, Mount Street, Helens, Bezymianny, and Pinatubo, by contrast, build pressure behind a structurally unstable dome or edifice in a way that can resolve gradually through ordinary venting or, catastrophically, through sudden failure, and the scientific community's own honest assessment, expressed across decades of published volcanological literature on exactly this category of volcano, is that this category remains structurally harder to forecast with precision than basaltic systems, regardless of how sophisticated the monitoring network watching it becomes. The pattern across all three of these historical cases, Mount Street, Helens, Pinatubo, and the contrast offered by Kilauea, is consistent and worth stating plainly. Escalating, ambiguous precursor activity at a dome-building stratovolcano has, across the modern instrumental record, resolved in markedly different ways, from successful, life-saving forecasting at Pinatubo to catastrophic, partially unanticipated failure at Mount St. Helens and at Bezymianny, with the deciding factor in each case turning on structural details internal to the specific volcano that even the best available monitoring technology can only partially observe. From the surface, that is the plain state of the science, as the agencies and the published research describing it would themselves characterize it. There is a fourth case worth adding briefly, because it returns us directly to Kamchatka and to a volcano in the same general region as Shiveluch, separated by roughly 200 kilometers. The 1956 eruption of Bezymianny, which we introduced earlier as the scientific template later applied to Mount St. Helens. What makes Bezymianny's case distinct from the other comparisons is the element of surprise involved. Unlike Mount Street, Helens, which had a documented history of past eruptions and was being actively monitored specifically because of concerning seismicity in the weeks beforehand, Bezymianny had shown essentially no eruptive activity in recorded memory before 1955, leading many scientists at the time to consider it effectively extinct. When seismic unrest began in the autumn of 1955, Soviet volcanologists noted it, but the volcano's apparent dormancy meant the unrest did not receive the kind of urgent monitoring attention a known active volcano might have warranted. Over the following months, a lava dome began growing within the summit crater, observed by scientists who, by their own later published accounts, did not fully anticipate the scale of what was building beneath it. On March 30th, 1956, the volcano produced a catastrophic lateral blast, devastating an area of approximately 500 square kilometers and demonstrating, for the first time in the modern scientific record, that a volcano without significant recent eruptive history could nonetheless produce one of the most violent eruption styles known to volcanology. Bezymianny's case is the cautionary one in this comparative set. It shows that absence of recent catastrophic activity is not, on its own, evidence of safety, a lesson Soviet and later Russian volcanologists carried directly into how KVERT now approaches every actively monitored volcano on the peninsula, Shiveluch included, regardless of how long it has been since that specific volcano's last major escalation. Holding all four of these cases together, Mount St. Helens, Pinatubo, Kilauea, and Bezymianny gives a more complete and more honest picture than any single comparison could provide on its own. Some escalating sequences at dome-building volcanoes resolve through successful forecasting and safe evacuation. Some resolve through eruption that, despite genuine scientific effort, still arrives with an element of surprise regarding its specific timing or scale. And some volcanoes, like Kilauea, behave with enough mechanical regularity that the entire question of surprise becomes less central to begin with. Shiveluch's own documented history, with eruptions in 1854 and 1964, that both arrived following periods of escalating but, at the time, ambiguously interpreted activity, places it closer to the Mount Street. Helens and Bezymianny end of that spectrum then to the Kilauea end, a placement the scientists at KVERT who study this exact mountain would, based on their published characterizations of Shiveluch's behavior, almost certainly agree with. The pattern in the modern record is clear. But we do not stop at the modern record. There is an older layer, tablets, manuscripts, oral traditions, documented predictions, that logged events matching this signature long before our instruments existed to confirm them. That layer is what comes next. One last point before we cross into that older layer. Every case examined in this section, Mount St. Helens, Pinatubo, Kilauea, and Bezymianny, was studied and reconstructed using instruments that did not exist before the 20th century. The deep human record we turn to next had none of those instruments, and yet, as we are about to show, it did not arrive at this category of mountain empty-handed. The name is Krasheninnikov, and the record is the first scientific account of Kamchatka ever produced, written by a man who walked this exact peninsula for nearly a decade before any of the agencies we have spent this report describing existed in any form. Stepan Petrovich Krasheninnikov was born in Moscow in 1711, the son of a soldier, and was selected as a young man for scientific training, specifically to join what became known as the Great Northern Expedition, a sprawling, multi-year Russian scientific enterprise led by Vitus Bering, tasked with mapping and documenting the Russian Empire's farthest eastern territories. Krasheninnikov spent 3 years traveling through Siberia, from 1733 to 1736, before being dispatched to Kamchatka itself in 1737, where he remained for 4 years, crossing the peninsula repeatedly on foot and by river, compiling the first detailed scientific description of its geography, geology, climate, flora, fauna, and native peoples ever produced. He personally observed and documented the Avacha and Klyuchi volcanoes, recorded earthquakes, and, critically for tonight's report, compiled what is believed to be the first written dictionary of the Koryak language and produced detailed ethnographic accounts of both the Koryak and the Itelmen peoples, the two indigenous groups who had inhabited Kamchatka, including the territory immediately surrounding Shiveluch, for thousands of years before Russian contact. His resulting work, Opisani Zemli Kamchatki, Description of the Land of Kamchatka, was published in St. Petersburg in 1755, shortly after his death, and remains, to this day, the foundational scientific and ethnographic text on the region, cited by historians, geographers, and anthropologists studying Kamchatka in every century since. A volcano on the peninsula now bears his name, as does an island and a bay in the Kural chain, a measure of how seriously his contemporaries and successors regarded the completeness of what he documented. What Krasheninnikov recorded about the Itelmen and Koryak relationship to the volcanoes of their homeland is precise, specific, and, by his own account, taken directly from sustained engagement with people who had lived alongside these mountains for as long as their own oral tradition could trace. The Itelmen believed that the volcanoes of Kamchatka were inhabited by spirits, beings the Itelmen and neighboring Koryak associated specifically with the interior of the mountains, and Krasheninnikov's ethnographic work documents these beliefs not as a passing curiosity but as a structured, central part of how the Itelmen understood their landscape and its behavior. Central to Itelmen cosmology is the figure of Kutkh, the raven, a creator deity whose mythology Krasheninnikov recorded in detail and whose stories remain documented and, remarkably, still actively transmitted among Itelmen descendants today. According to the tradition Krasheninnikov preserved and that contemporary Itelmen language keepers continue to describe, Kutkh created the land of Kamchatka itself out of the body of the king salmon, and in doing so infused his own fire spirit directly into the mountains of that land, while giving life to its rivers and teaching the first people to hunt and fish. The fire spirit Kutkh placed inside the mountains is not, in this tradition, a metaphor applied loosely after the fact. It is presented as a literal, structural feature of how the mountains themselves came to exist, an explanation for why certain peaks burn and others do not, embedded directly into the creation account of the land. Krasheninnikov also specifically documented the belief, held among the Itelmen, that what lived inside an active volcano was not benevolent. His ethnographic notes describe these as evil spirits, beings the Itelmen propitiated through ritual offerings made at specific sites near their villages, separate from the household spirits kept within their dwellings, a religious practice Krasheninnikov observed directly and recorded as distinct from, though related to, the broader reverence shown toward Kutkh. The structural detail worth noting here, and the detail that bears directly on tonight's report, is this. The Itelmen tradition Krasheninnikov documented does not describe volcanic activity as random or arbitrary. It describes a mountain that burns as a mountain inhabited, a mountain whose behavior reflects the disposition and activity of something dwelling within it, requiring ongoing attention, respect, and ritual acknowledgement from the people living in its shadow, precisely because that disposition was understood to be capable of changing, sometimes with violent consequence, and a community that maintained the proper relationship with that presence was understood to fare better than one that did not. The preservation and transmission of this material deserves its own scrutiny because the reliability of any ancient or traditional account rests entirely on how faithfully it has been carried forward, and this is a point where Krasheninnikov's record holds up unusually well under examination. Unlike oral traditions reconstructed centuries after the fact from fragmentary later sources, Krasheninnikov's account was produced through direct, sustained fieldwork, 4 years of continuous residence among the people he was documenting, during a period when Itelmen culture remained largely intact and prior to the more severe disruptions of later Russian colonial administration, disease, and forced cultural assimilation that significantly reduced the Itelmen population and cultural continuity in the centuries that followed. Krasheninnikov's manuscript was reviewed and published by the Imperial Russian Academy of Sciences, the same institution that would later elect him to membership, subjected to the kind of institutional scrutiny that, while certainly reflecting the scientific conventions of its own 18th century moment rather than modern anthropological methodology, nonetheless represents a far more rigorously documented source than most ethnographic material surviving from this period and this region. Subsequent scholarship, including the work of later Soviet and post-Soviet ethnographers who continued studying Itelmen and Koryak communities into the 20th and 21st centuries, has consistently corroborated the core elements of what Krasheninnikov recorded regarding Kutkh, the fire spirit tradition, and the broader volcano spirit cosmology, even as the Itelmen language itself has come under severe pressure, with contemporary language revival efforts centered in the village of Kovran, working actively to keep both the language and its associated oral traditions, including the Kutkh material, alive for new generations. The Itelmen themselves, in their own recent public accounts of their language and cosmology, continue to describe Kutkh's fire spirit and its placement within the mountains in terms remarkably consistent with what Krasheninnikov recorded nearly 270 years ago, a continuity of transmission across multiple generations and through severe historical disruption that lends the tradition considerably more weight than a single isolated textual source might otherwise carry. That number will matter again before this section closes. We turn now to the second tradition, drawn from a different people entirely, with no significant documented historical contact with the Itelmen or Koryak of northern Kamchatka, separated by language, family, religious framework, and several hundred kilometers of the Kuril Island chain. The Ainu, indigenous to Hokkaido, Sakhalin, and the Kuril Islands, whose traditional territory extends to within striking distance of Kamchatka's southern volcanic systems, and whose own relationship to fire and mountains developed through an entirely independent cultural and religious trajectory. Central to Ainu religious life is the concept of kamui, spiritual beings or deities understood to inhabit the natural world in its entirety, including rivers, animals, weather, and, specifically and centrally, fire. Among the kamui, one of the most significant is Kamui Fuchi, the fire goddess, who occupies a position of particular reverence within Ainu cosmology, specifically because fire itself, kept burning continuously in the hearth at the center of every traditional Ainu dwelling, was understood as her living, ongoing presence within the human household, a guardian spirit and an intermediary between the human and spiritual worlds, addressed in prayer and ritual whenever offerings were made to any other kamui, since communication with the wider spirit world was understood to pass through her domain first. Some linguistic scholars studying the Ainu language have proposed, with appropriate scholarly caution regarding etymology this old, that the name of Japan's most famous mountain, Fuji, itself may derive from Fuchi, the name of this same fire goddess, given the documented historical presence of Ainu peoples across the broader region, including areas near Mount Fuji prior to later Japanese settlement, though this etymology remains debated among specialists rather than settled fact, and we present it here with that appropriate qualification rather than as established certainty. What matters most directly for tonight's comparison is the broader Ainu conception of mountains as kamui-inhabited entities, a conception documented extensively by anthropologists working with Ainu communities and reflected in place names, ritual practices, an oral tradition still actively maintained, particularly around Hokkaido's volcanically active regions, including the Toya-Usu Geopark, a UNESCO-designated site formed by a massive volcanic eruption roughly 110,000 years ago, and still home to active volcanism today, where contemporary Ainu cultural practice continues to describe the landscape's volcanic features in terms drawn directly from this same fire spirit framework, treating an active volcanic landscape not as an inert geological backdrop, but as a space in active, ongoing relationship with the Kamui who inhabit it. This framework extends well beyond Kamui Fuchi specifically into a broader pattern within Ainu sacred geography, worth noting for the strength it adds to the comparison. Mount Kamui, a stratovolcano on the rim of the Mashu caldera in eastern Hokkaido, carries a name that translates directly as Mountain of the Gods, a designation reflecting the same underlying conception that certain mountains, particularly those with active or recent volcanic behavior, are understood as inherently sacred, inhabited spaces rather than neutral terrain. Elsewhere in Hokkaido, documented Ainu tradition surrounding sites such as Mount Arashiyama near the Ishikari River describes specific peaks as places of such concentrated spiritual significance that travelers passing nearby by boat were expected to remove their headgear and adjust their clothing in a gesture of formal respect before passing, a practical ritual observance built directly around geographic features the Ainu understood to be charged with the presence of Kamui. The consistency of this pattern, mountains as named, individually recognized dwelling places for specific spiritual beings, recurring across multiple distinct sites throughout Ainu territory rather than appearing as an isolated belief attached to a single location, strengthens rather than weakens the comparison to the Idolman material, since it demonstrates that both traditions developed not a single isolated myth, but an entire systematic cosmological framework for understanding volcanic and mountainous terrain. As inhabited and responsive, a framework robust enough to be applied consistently across an entire homeland rather than invented once and never generalized. The structural correspondence between the Itelmen and Koryak account that Krasheninnikov recorded and the Ainu account independently documented by generations of subsequent anthropologists is, on close examination, considerably more specific than a generic shared instinct that fire is sacred or dangerous. Both traditions describe fire and the mountains that produce it as the dwelling place of a specific, named spiritual presence, rather than as an impersonal natural force. Both traditions describe that presence as requiring ongoing ritual acknowledgement from the human communities living nearby, rather than as a force that simply exists independent of human relationship to it. And both traditions develop this framework independently, across separate language families, separate religious systems, and a documented historical gap in direct contact between the two peoples in a region of the world, the volcanic arc running from Kamchatka down through the Kuril Islands into Hokkaido, that happens to be one of the most consistently active stretches of stratovolcanism on the entire planet, the exact category of volcano, andesitic, dome building, capable of long, quiet periods, followed by sudden, violent escalation, that both Shiveluch and Bezymianny belong to. There is a name in the ancient record that matches this location precisely. We are not there yet. We turn now to the third text, the one furthest in both geography and time from Kamchatka, with no plausible route of historical contact connecting it to either the Itelmen or the Ainu material. The Book of Revelation, chapter 16, verses 8 through 11, and chapter 8, verses 7 through 11, composite passages within a text most biblical scholars date to the latter decades of the 1st century CE, traditionally attributed to John of Patmos, written during a period of Roman imperial pressure on early Christian communities across Asia Minor. Revelation's broader apocalyptic vision includes specific, recurring imagery of fire falling from the sky, mountains and great masses burning, and a third portion of the earth, the sea, and the waters being affected by what the text describes in the language of burning and bitterness. The relevant passages describe something resembling a great mountain, burning with fire, being cast into the sea, with a third of the sea becoming blood, and a third of its creatures dying, and separately describe a star, called wormwood, falling and burning like a torch, making a third of the rivers and springs bitter. Language scholars of apocalyptic literature have long noted draws specifically and deliberately on the conventions of the genre, conventions that frequently used real volcanic and seismic phenomena, fire, ash, darkened skies, poisoned water, as source material and vivid sensory vocabulary for describing cosmic and political upheaval, even when the immediate referent of a given passage was understood by its original audience to be political rather than purely or literally geological. This is an important scholarly distinction, and an honest report owes it to you directly rather than glossing over it for effect. Serious biblical scholarship does not generally read Revelation's burning mountain imagery as a direct, literal forecast of any specific volcanic eruption, ancient or modern, including any eruption at Shiveluch. The text's primary scholarly context is apocalyptic and political, addressed to specific first-century communities living under specific first-century imperial conditions. The text's transmission history is itself well documented and extensively studied, surviving in Greek manuscript traditions, including early papyrus fragments and later codices, cross-referenced across centuries of textual scholarship, translated and retranslated, debated in every era since its composition regarding both its authorship and its intended meaning, with modern critical scholarship generally dating its composition to the reign of the Roman Emperor Domitian in the final decade of the 1st century CE, a period of documented pressure on early Christian communities across the Roman province of Asia in what is now Western Turkey. What we are pointing to here is narrower and more defensible. The specific vocabulary the text reaches for, burning mountains, fire falling from a darkened sky, water turned bitter or deadly, a third of something destroyed, is vocabulary that correlates closely, structurally, with the observable sensory experience of living through a major explosive volcanic eruption, ashfall darkening the sky, water sources contaminated by fallout, fire and incandescent material descending from above. An experience the Eastern Mediterranean world of the 1st century CE was not unfamiliar with. Given the documented volcanic activity of the region, including Vesuvius's eruption in 79 CE, within living memory of Revelation's likely composition window, an eruption whose detailed eyewitness account by Pliny the Younger remains one of the most precise, first-hand descriptions of a major explosive eruption surviving from antiquity, describing darkness falling at midday, ash blanketing the landscape, and a sense among observers that the natural order itself had been suspended. Whether or not Revelation's author intended any literal volcanic reference, the descriptive language he reached for to convey ultimate catastrophe drew on the same basic sensory vocabulary that the Itelmen, the KVERT, and the Ainu independently developed entire religious frameworks to describe and manage: fire that falls, mountains that burn, water made unsafe, skies made dark, and a portion, repeatedly specified as a third, of the world rendered unlivable in the aftermath. The data is in the record, the interpretation belongs to you. There is a further point of synthesis worth drawing out before we move to the closing portion of this report, because it concerns not just the content of these three traditions, but their method, the way each one arrived at and preserved what it knew. The Itelmen and KVERT material reached us through direct, sustained ethnographic fieldwork, a trained observer living among the people he was documenting for years at a time, recording what he was told in a systematic, scholarly format that has since been corroborated by generations of subsequent researchers. The Ainu material reached us through a comparable, if independently developed, tradition of anthropological documentation, supplemented by the active, ongoing testimony of Ainu cultural practitioners who continue to describe and practice this cosmology today in their own words, in the present tense, rather than as a closed historical curiosity. The Revelation material reached us through an entirely different channel, textual transmission, across nearly 2 millennia, copied, translated, and subjected to the kind of close philological and historical scrutiny that biblical scholarship has applied to it in every century since its composition. 3 different methods of preservation, 3 different standards of historical verification, and yet the underlying observational content that certain mountains burn, that the burning follows patterns worth encoding into a culture's deepest stories, that the people closest to the danger took the obligation to watch and remember seriously converges across all three. We promised earlier in this report that we would return to a specific number once you understood what it measured, and to the question of how three separate traditions, with no documented contact between them, could independently arrive at structurally similar accounts of what a burning mountain represents. The number is the volume of material Shiveluch moved in 1,964, nearly 2 cubic kilometers, displaced in barely over an hour, by a mountain that had given 73 days of warning in the form of accelerating earthquakes the agencies of the time could record but not yet fully interpret. The traditions are the Itelmen account of a fire spirit inhabiting the mountain, requiring acknowledgement and capable of violent disposition, the Ainu account of Kamui Fuchi, fire as a living, relational presence, rather than an inert force, documented independently across the strait, separating Kamchatka from Hokkaido, and the apocalyptic vocabulary of revelation, developed in a different hemisphere entirely, reaching for burning mountains and darkened skies to describe the outer limit of catastrophe. None of these traditions had access to seismometers. None of them could measure cubic kilometers of displaced material or track ash plume altitude in flight levels. What they had instead was sustained, careful, multi-generational observation of what mountains like this one actually do, encoded into the only systems of knowledge transmission available to people without written instrumentation: religious language, ritual practice, and story. The structural agreement between what those systems independently encoded and what KVERT's instruments are recording at Shiveluch this week is, at minimum, a remarkable correspondence. We leave the rest of the interpretation where it belongs, with you. As this report is filed, here is where things stand. Shiveluch Volcano, on Russia's Kamchatka Peninsula, remains at aviation color code orange following a sequence of red-level explosive events recorded across late May and early June of this year. The dome at the summit of Young Shiveluch continues to grow, fed by magma rising from depth, and KVERT's most recent bulletins describe seismicity and thermal signatures consistent with an actively pressurized system rather than a system winding down. Tonight, the instruments show continued elevated tremor, continued degassing from both the dome surface and episodic explosive venting, and continued uncertainty, plainly stated by the agencies responsible for tracking it, about whether the current sequence resolves the way the majority of this volcano's 24+ documented eruptive episodes have resolved through gradual subsidence, or whether it follows the rarer and more violent path the mountain took in 1854 and again in 1964. It is worth sitting, briefly, with the full arc of what this report has covered, because the distance traveled across roughly 90 minutes is considerable, and the closing of a report like this one is the place to draw the full picture back together rather than leaving it scattered across the sections that built it. We began with a remote volcano most of our audience had likely never heard of before tonight, on a peninsula most could not locate on a map without effort, and we end having traced that single mountain's behavior across nearly 3 centuries of written observation through the first-hand account of an 18th century Russian naturalist who walked its slopes on foot, into the living oral tradition of the people who called this land home before Russia ever arrived, across the strait into a second indigenous tradition entirely, and finally into a text written on the opposite side of the planet, in a different language, under a different empire, 2,000 years before any of tonight's satellite imagery existed. That is the method this channel exists to apply, night after night, to whatever event the agencies are currently tracking. We covered, across this report, the full instrumental picture, the specific ash plume measurements from the Tokyo Volcanic Ash Advisory Center, the dome growth tracked by KVERT since February of this year, the aviation and economic consequences for transpacific air traffic, and the detailed reconstruction of the 1,964 eruption sequence, the 73 earthquakes in the day before the edifice failed, the 75 minutes in which nearly 2 cubic kilometers of material were displaced, and the honest, sober comparison to Mount Srit, Helens, Pinatubo, and Bezymianny that situates Shiveluch's current behavior within the broader, documented range of how dome-building stratovolcanoes have behaved across the modern instrumental record. We then went further, into the ethnographic record Stepan Krasheninnikov preserved nearly 270 years ago, documenting the Itelmen and Koryak understanding of Kutkh and the fire spirit placed within Kamchatka's mountains, a tradition still actively maintained and transmitted by Itelmen language keepers today. We crossed the Kuril Island chain into Ainu cosmology, examining Kamui-Fuchi and the broader pattern of named, individually recognized mountain spirits documented across Hokkaido's sacred geography, and we closed with the apocalyptic vocabulary of Revelation, examined with the scholarly care that text deserves, tracing the structural correspondence between its imagery of burning mountains and darkened skies and the lived sensory experience that the Itelmen, the Koryak, and the Ainu independently built entire religious frameworks to describe. In the coming days and weeks, here is specifically what is worth watching, drawn directly from the monitoring framework KVERT itself uses. Watch for any further acceleration in the frequency of explosive events at Shiveluch beyond what has already been recorded this month. KVERT issues updated technical bulletins multiple times per week during active sequences like this one, available directly through the Kamchatkan Volcanic Eruption Response Team's public reporting channels. Watch the aviation color code itself, which functions as the clearest single public indicator of how the agencies tracking this volcano are reading its current state, with any sustained shift to red, rather than the episodic red then orange pattern recorded so far this month, representing a meaningful escalation worth taking seriously. Watch for any Tokyo Volcanic Ash Advisory Center bulletin describing ash reaching altitudes beyond flight level 350, the threshold this month's larger events have approached, but not significantly exceeded. Watch the Global Volcanism Program's weekly volcanic activity report, which compiles KVERT's findings alongside reports from observatories worldwide and provides the kind of standardized, comparative context that allows this exact kind of before and after historical analysis. Watch, more broadly, whether KVERT's bulletins begin describing measurable ground deformation at the summit, distinct from simple continued dome growth, since deformation of that kind was a documented feature of the precursor activity at Mount Sreet, Helens in 1980, and would represent the clearest possible signal that the current sequence is moving towards something closer to structural failure rather than continued, survivable venting. And watch any change in the official guidance given to residents of Klyuchi and Ust-Kamchatsky specifically, since regional authorities have, in past comparable episodes at this volcano, adjusted their public guidance in close step with what KVERT's instruments were showing, and any shift from the current posture of no mass evacuation required toward more urgent language would itself be a significant data point independent of the raw technical readings. We want to be honest, one final time, about the limits of everything we have just told you. No agency tracking Shiveluch, not KVERT, not the Tokyo Volcanic Ash Advisory Center, not the Global Volcanism Program, has stated that a 1964 scale event is imminent, and we have not made that claim either at any point in this report. What we have done is show you, as completely and as carefully sourced as we are able, the full instrumental picture of what this volcano is doing right now, the documented historical range of how this exact volcano and others structurally like it have behaved when producing this kind of escalating activity, and the older human record, predating every instrument we described, that this exact place has accumulated across the centuries people have lived close enough to watch it. We have tried, throughout, to hold the modern data and the older record with the same standard of evidence, tracing every claim to a real, findable source, and we have tried not to let the genuine drama of an erupting volcano on the far edge of Siberia tip this report into the kind of manufactured urgency that erodes trust rather than earning it. It is worth sitting, for a moment, with what it means that three separate human groups, separated by thousands of kilometers, by language families with no demonstrated common ancestry, and in the case of Revelation, by an entirely different continent and an entirely different religious tradition, each arrived independently at frameworks describing burning mountains as inhabited, responsive, and capable of violence that demanded acknowledgement. We are not asking you to conclude that the Itelmen, the Ainu, and the author of Revelation were somehow receiving the same literal information from the same literal source. We are asking you to notice that sustained human observation of this specific category of natural phenomenon, an andesitic stratovolcano's tendency to build quietly and then, on occasion, fail violently and with limited warning, produced remarkably consistent descriptive instincts across cultures with no contact between them, instincts that, read carefully, encode something true about how these mountains actually behave, regardless of the religious vocabulary used to express it. That is, in its own way, exactly what KVERT's modern instruments are doing too, building an inferential model of an unseen process, magma moving at depth, from the surface, signals that process produces, and trying to read those signals correctly before the mountain finishes speaking for itself. No one watching Shiveluch tonight, not the seismologists in Petropavlovsk-Kamchatsky, not the analysts in Tokyo, not the Itelmen elders in Kovran who still teach Kutk's story to their children, can tell you with certainty what this mountain does next. What all three groups share, separated by centuries and by entirely different vocabularies for describing the same underlying phenomenon, is the discipline of watching closely, recording plainly, and resisting the temptation to claim more certainty than the evidence actually supports. That discipline is the thread connecting an 18th century naturalist's field notes to this month's satellite bulletins to a 2,000-year-old apocalyptic text, and it is the same discipline this report has tried to hold throughout. Tonight's report covered a single volcano on a remote Russian peninsula most viewers will never visit, and it took us from a live aviation advisory through nearly 3 centuries of written eruption history into an 18th century ethnographic record across the Kuril Islands into Hokkaido, and finally into a 2,000-year-old apocalyptic text in service of one single, sustained question: does the deep human record have anything truly useful to tell us about what a currently active volcano might do next? We think tonight's evidence suggests it does, at minimum, preserve a careful record of how seriously the people who lived closest to this exact kind of danger, for the longest periods of recorded and remembered time, took the obligation to watch carefully and respond to what they saw. The layer beneath the headline is what we file every night, and it is the layer most coverage of a story like this one does not have the patience or the sourcing discipline to reach. If that combination of live verified data and carefully sourced historical and ancient context is useful to you, subscribing means you will not miss the nights when the correspondence is this precise. And we would like to know, in the comments, whether you think the pattern we traced tonight holds up. What you received tonight was a single mountain, traced from a live aviation advisory through 3 centuries of written history into a record older than any instrument, and that is what this channel files every night a verifiable event warrants it. We do not cover speculation. We cover what an agency confirmed, what the historical record shows, and where the ancient layer truly overlaps, without forcing a connection that is not there. Subscribing means the next correspondence this precise does not pass you by, and we read every comment, so tell us what you would want this kind of treatment applied to next. The data is on the record. The interpretation is yours. We continue to monitor. We will report again at last light.